to continue looking at the rational zero theorem, and we're going to find all the possible rational zeros. We're going to start out with, let's just start out with q, or let's not use q. Let's go with r of x is equal to, we'll go with 3x squared plus 2x minus 1. So what we want to do is we want to first find the factors of the constant, which is 1, and the factors of our leading coefficient, which is 3. So the factors of 1 are just going to be positive, negative 1. Factors of 3 are positive, negative 1, and positive, negative 3. So remember, my possible zeros, p divided by q, are going to be 1 divided by 1. 1 divided by 1 is 1. And 1 divided by 3, which is a 1/3. So if I were to actually list these out, it would be a positive 1, negative 1, positive 1/3, and a negative 1/3. So I actually have 4 possibilities because I have the positive, negative version of each one of these. Let's look at another one where we have a few more, and let's look at m of x is equal to a 4x to the 5th minus 2x to the 4th plus 30x to the 3rd minus 15x squared plus 50x minus 25. Now the nice thing about finding all the possible zeros is I literally just look at the leading term and the constant. So if I look at the constant, my p, the factors of my constant are going to be 1, 5, and 25. Because 1 times 25 gives me 25, 5 times 5 will give me 25. Then I look at the leading coefficient, which are 1, 2, and 4. Because 1 times 4 gives me 4, 2 times 2 gives me 4. P divided by Q. Remember, this is where my Q comes from. This is where my P comes from. So I'm going to take each of these and divide it by 1 to start off with. So I'm going to have plus or minus 1 divided by 1, plus or minus 5 divided by 1, plus or minus 25 divided by 1. Then I'm going to divide each one of those by a 2. So positive, negative 1 divided by 2, positive, negative 5 divided by 2, and a positive, negative 5 divided by 4. Then I will take the 25 and divide it by, nope, sorry, I should have done this one as the 25 divided by 2. Then I'm going to take each one of these and divide it by the 4. So that should be 1 divided by 4, 5 divided by 4, and 25 divided by 4. I apologize. So here are all my possible rational zeros. Now again, if it is not in this list, it is not going to be a rational zero of this particular function. So while I'm doing synthetic division or anything like that, I should not even attempt a 4, a 2, a 3, anything like that, because those are not possible zeros. So this is the whole purpose of this rational zero theorem, is to find us a list that cuts it down from an infinite number to a much smaller number of possibles for us to try.